Also want to remind you, you see the cart's been moved into the room. We're getting ready for the cereal drive. So next week, Monday, Wednesday, and Friday during office hours, you can bring in your 2 full-size boxes of cereal or your 2 12 count boxes of Pop-Tarts, all right? What's it for? It's for the homeless children in our city. So it's gonna go to Dayspring Center, to Holy Family Shelter, and then St. Vincent de Paul Food Pantry if we have anything left over. All right, so it's going to homeless children. So let's think about this for a minute. When you sit down to breakfast, some of you probably don't even eat cereal, but if you did eat cereal, would you want to sit down to a bowl of Fiber One? No. So don't bring that. Bring something you like. And if you are like a healthier type person, then bring something like Honey Nut Cheerios. They actually love that. They request that. They love Honey Nut Cheerios. Life cereal, that kind of stuff. Bring that kind of stuff. Or any flavor of Pop-Tarts, but they just got to be the 12 count boxes, okay? The bigger boxes. All right? Everybody good with that? It's 2 test points. And you might think that doesn't make any difference, but it can. It can make, those are test points. Those are big points. And it can make a difference. But I hope that's not your motivation. I hope your motivation is, we have hungry kids in our city. We have kids that have to go to school and they don't have anything to eat. Okay? They're in shelters. They are homeless. They are in shelters, family shelters. Okay. All right, so we had our pep talk. Also, next Wednesday is the blood drive. I encourage you, please, we have a dire shortage of blood in our community. Please, if you can give blood, please consider doing that next Wednesday. The sign-ups are all over the place, so if you scan it, and you're in. Consider doing that. All right, here are our practice problems, all right? Problem number 1. So let's go through the steps we're gonna go through to find the sine of pi over 6. Yesterday, you guys were rocking this. Let's see if we remember. What is the first thing we're going to do? We're going to change 5 pi over 6 into degrees. You will have a baby calculator tomorrow, or the quiz. That's the only thing you'll have, but you will have one. So you're going to take 5 times 180 and divide it by 6, and you're going to get the sine of 150. Now that is not the answer to the question. Next step, draw your picture. Now I'm going to draw a triangle somewhere. I have to figure out where to draw it. There's my setup. Where am I going to draw it? I'm going to draw it over here, aren't I? So there's 150. Now I'm going to make my triangle. And I'm going to figure out that angle right there. That's the important one. The angle in the triangle at the origin, that angle right there. How big is it? 30. And you know it's 30 because 180 minus 150. As soon as you put a 30 there, you know a 1 goes here, a 2 goes here, and a root 3 goes here. How do I know that? It's my special triangle, 30, 60, 90. And then I have to put on the brakes for a minute and remind myself I am not in quadrant 1. Therefore, something is negative. What's negative? 33. Okay? Remind yourself always to put in your negatives if you're not in quadrant 1. Okay, I want the sign. What's the sign? 1 over 2. Opposite over hypotenuse, 1/2. Now, Nora, new to us, if you have your unit circle memorized, you can absolutely do this with the unit circle. I don't require that with this class, so you got it, you got it. If you don't have it memorized, then you'll have to start doing it like we do. All right, Next, cosine pi. We're gonna go through exactly the same series of steps. So what was the first thing we did? Change the radian measure into degrees. So that's an easy one, that is 180. So then I draw a picture. Oh, wait a minute. Isn't this 180? Uh-oh. What do I do when I'm on an axis like that? I draw my circle. And because it's the easiest thing to do, I let the radius be 1. So that means I'm over 1, up 1, out 1. What's that point? I need an X and a Y now. What's that point? Here's the origin, left 1. That is the point, -1, 0. Right? So X is -1 and Y is 0. What's cosine? Well, I can't really do adjacent or hypotenuse because I don't have a triangle, so I have to remember it's X over R. So X over R would be -1 over 1, which is -1. Tangent, -3 pi over 4. What have we got? So tangent, -135. Now, you guys remember, these are multi-step problems. So you're not done. That is not the answer. Don't write 135. That is not the answer. Actually, it's negative, isn't it? -135. We have to draw a picture and find our answer, okay? So what does that look like? A negative angle. Instead of going up and around, I'm going to go down. Down and around. Right? So where's 135? Sophia's pointing down here. Isn't this 135 down here? Negative. So then I make my triangle. And this angle right here is the one I care about. How big is that angle? This one right here. Focus right there. That's the one you care about. How big is it?
45.
So that automatically means my sides are 1/√2. Pause. Where are the negatives? On both ones? I want tangent. What's tangent? -1 over -1. It looks like the tangent is 1. All right. One more practice problem. Remember, your quiz will have just 2. We're just practicing a few extras. So the last one is the cosecant of 4 pi over 3. Cosecant 4 pi over 3. Step 1. Yoo-hoo! Change it into degrees. So who's got that done? This is the cosecant of what? 240. All right. Step 2. Draw a picture of it. Where's 240? Down here. That's 180 and that's that's 270, 240, somewhere in between. Make your triangle, and your triangle is always part of the butterfly bow tie. This angle right here is the one I need. So that's the angle made by the 180 line and the 240 line. So what will that be? What is it?
30.
I'm hearing 30 and I'm hearing 60, and it's one. It's 60. Stop right now. Where's this finger? What angle is that finger? 180. What angle is that finger? What angle is that finger? 240. How much is between 180 and 240? 60. That's right. Yeah, it's 60. 240 minus 180. These two lines are forming it. All right, the minute you make that 60, this is root 3, this is 1, and this is 2, because you have a 30, 60, 90 triangle. What's negative? Root 3 and the 1 are both negative. I want cosecant. Reciprocal of sine. So that means hypotenuse over opposite. So 2 over negative root 3. Or negative 2 root 3 over 3. Now, if you don't want to wait till Monday to take this quiz, you can stay after school and do it. It'll only take a couple minutes because it's only 2 problems. But otherwise, you gotta wait till Monday, because that's when we're taking the quiz. Okay? All right, let's get our notes out. Nobody has any questions about those, right? You know what quiz is over, right? Yeah. Okay. Yes, 0 is also negative. When I label my axes and I put 0 here, wouldn't that also be 360, folks, all the way around? Yeah. So remember that is also 360. Okay. Now we are in our notes. And we are ready to start sketching. So we are going to spend this whole day, this whole period, sketching sines, cosines, and tangents. If you flip your orange sheet over, the back side has the graphs. Now, since it's on the orange sheet, that means it's something that you should know, okay? You need to know it. All right, so let's see. In our notes, first one is y equals sine x. We are going to sketch it, just like it's done on the orange sheet, and we're going to discuss its amplitude and its period. Right, and right now you may or may not know what those words mean, and that's okay, we're going to figure it out. But first we're going to sketch it. When we sketch a sine or cosine, we go up 1 and down 1. I don't know if you remember that from your BFFs or not, but that's the way it looked on your BFF card. And then, with the sine, you had a dot at the origin, and you had a hill, and then you had a valley. Remember that from your note card? And at the time, that was all you had. But now we have to label this axis too. And there are going to be 4 labels on that axis. Why are there 4? Well, obviously we have to label the top of the hill. That's called our maximum. This is an x-intercept, so we label it. This is our minimum, so we label it. And then our ending point. Okay? Those 4 sections, 1, 2, 3, 4, are actually the quadrants when you were, the problems we were doing before. So think about this. When I set this up, isn't this how I labeled it? That's exactly how this gets labeled. So 90, 180, 270, 360. Those are the horizontal labels for your sine curve. Now, we talked about this before when we did our BFFs a long time ago. But the sine curve doesn't start here and stop here. It actually keeps going, remember, forever and ever and ever. We don't need to draw all that though, because if I draw one hill and one valley, then the next part would be just another hill and another valley and another hill and another valley, and it just keeps repeating itself. That part that repeats itself, in this case, a hill and a valley, is called a period. The period is the part of the graph that you just keep repeating. So what is the period? What is the length of a period? One hill, one valley for a sine curve. 360 degrees. That's the period. One time around the circle. When you go this way, one time around. Think about that, guys. If I go around again, will I just be doing the same thing I did the first time? Yeah, one hill and one valley, so there's no point in doing it. Here's the hill, here's the valley. Another hill, another valley, on and on. So the period's 360. Amplitude is the height of the curve. So the height of the hills is 1. That's a standard sine curve. That should be exactly what's on your orange sheet. Okay? Now what about a cosine? Well, what do you remember from the BFFs about cosines? Aren't they basically the same? Except what? What is the difference when we sketch a cosine? It starts at 1. So all the labels are exactly the same. Everything about the curve is exactly the same except where it starts. So a sine curve starts at the beginning of the hill. A cosine starts at the top of the hill. So down it comes, up it goes, and there it ends. So it starts at the top of the hill. So we have half a hill here. Then we have our whole valley. And then we have the other half of the hill over here. I know that looks very strange. But if we continued it, do you see the sine curve in there, the wave in there, the whole wave? So this is what your cosine looks like. This is what you're going to sketch. You're going to start it right here, end it right there, and go down and back up. What is the period of a cosine? 360. And the amplitude of a cosine, 1. They're exactly the same curve, they're just shifted each other. Now the tangent was not one of our BFFs. It is an entirely different animal altogether. The tangent, you can see on your orange sheet, isn't a wave. What BFF does the tangent kind of look like? The cube. That's exactly right. Except cubes don't have asymptotes. And the tangent does. So the tangent curve has an asymptote at -90, an asymptote at +90, and then a squiggle through the origins. That is your tangent. That's all there is to it. Now, just like with those guys, it goes on. So there's another asymptote out here, and another squiggle, and another asymptote, and another squiggle, but you don't have to do all that. One is enough. Asymptote, asymptote, squiggle. Tell me about period and amplitude for this guy. How far is it from start to finish? Oh no, 180. Isn't it 180 degrees from start to finish? We're going from negative 90 to positive 90. Here we were going from 0 to 360. Here we're going from negative 90 to 90. How about amplitude? Remember what's amplitude? Amplitude is height. We don't have any. Why do we have none? Because there is no highest point. Doesn't the tangent just keep going? So the tangent will never have amplitude. Because it doesn't have any hills. It doesn't have any peak. Alright, so that's our basics. Those are our basics. Everything else we do today is going to be a variation of those three. So keep those three in front of you. You have them in your notes and you have them on your orange sheet. Keep them in front of you because now we're going to put some numbers in. Someone impressed me greatly. What does a number out in front of a function do? We talked about this back in chapter 1. What does it do?
I don't know.
Be careful, you're on the right track. Raise it probably isn't right. If we put a +3 on the end, that would literally lift it up 3, remember? But this, no. To move to the left and right, we have to have plus and minus on the x. Yes. This multiplies the amplitude. Now, I'm using the word amplitude now because we're in trigonometry, but she said multiplies the height. Isn't that the same thing? Okay, so what does that mean? Well, let me get rid of that because we don't want that in there. That means that normally these hash marks here would be 1 and -1. Well, now they're going to be 2 and -2. So if I were doing this on legit graph paper, it would be twice as tall. It has no impact on these labels whatsoever. And it doesn't impact the general shape. So I'm going to start at the origin. And now I'm going to go all the way up to 2, back down. There's my hill. And then all the way down to -2 and back up. Tell me about amplitude and period for this. Amplitude's 2. Amplitude's 2. It was 1. In the original picture it was 1, but I times it by 2. So now it's 2. What about the period? It's still 360. Hasn't changed. Still 360. Okie dokie. All right, now we're doing -3 cosine. We already know what the 3 does. What does the 3 do? Multiplies my amplitude. So my amplitude's going to be 3. So that means 1, 2, I'm all the way up to 3 and all the way down to -3. My period hasn't changed. Haven't done anything to change that. negative? A what? Flips it upside down. So where does a cosine normally start? Up here, at the top of the hill? Well, where's this one going to start? At the bottom of the valley. So it's going to start down here. And whoops. And it's going to look like that. Now again, it looks very strange, but if you think about it in context, the picture makes a little more sense, doesn't it, when you think about it? This is the second half of the valley, the whole hill, and then the first half of the valley. Caution, there's a -3 out here, but the amplitude is still 3, because amplitude is height. How high is that hill? 3. The negative is important, but only in terms of turning the picture upside down. Amplitude and period are positive numbers, always. Got it? Okay. Negative tangent. What do you think about negative tangent? I haven't changed it in any way except turned it upside down, right? So hopefully, while I'm messing around up here, you've already got it graphed. What does the tangent look like? We got an asymptote at -90, another asymptote at +90. Normally, I squiggle up and through the origin, but upside down, I will squiggle down and through the origin. What is my period? 180. And what is my amplitude? Tangents don't have amplitude. All right? Easy enough. Oh boy, now we're ready for G. Sine 1/2 x. Do you notice that that 1/2 is in a different spot? Okay, so that means it's going to have a different impact. The number out in front multiplies amplitude. That number right there multiplies amplitude. Does anyone happen to remember what a coefficient on x, is that 1/2? Yeah. What a coefficient on x does? It divides the width. In other words, it divides the period. So the number out in front is a multiplier. The coefficient on x is a divider. Okay, here we go. What does that mean? Well, I'm going to go ahead and draw my regular sine curve. No labels, just my regular curve. Right? Now, what's my amplitude? I don't think these have changed. Aren't these still 1 and -1? Okay, now, what about the horizontals? Well, now hang on. Under normal circumstances, and I'm going to put my correct answers are going to go here, okay? These are going to be my correct answers. I'm going to write my originals down here. This would be 90, 180, 270, and 360. Would you agree with that? Those are the originals. But now, because of that, I need to change those, okay? Hey, Lincoln, what does Mrs. Bender do when you're in the middle of a show choir performance and you close your eyes? She would probably not be happy, right? Let's be a Lincoln alert. 2 days in a row. Let's not do it anymore, okay? Stay awake and alert. Stand up if you need to. Okay. This number divides these. So the actual right answers that I'm going to put in the squares are 90 divided by a half, 180 divided by a half, and so on. All my horizontals, those are my period numbers, horizontal, they get divided by a half. Okay? Now if you're struggling with getting the right answer on your calculator, 1/2 is the same as 0.5. So it might be easier for you to divide by 0.5. I don't know, it doesn't matter to me, but somehow you have to get 180, 360, 540, and 720. Those are the correct answers. So now, while my amplitude is still 1, my period is 720. In other words, twice as long as it was originally. So how do I change this? I put a number out in front and that multiplies it. How do I change this? I put a coefficient on x and that divides it. That divides it. That number's a divider. All right, so let's try h. Cosine 2x. Cosine 2x. Now, start with what you know. When it gets around to test day, quiz day, you are going to get half credit if you even have the right shape. But you gotta get the right shape. Let's start with that. So we know what a cosine looks like, right? Cosine does this. Remember, when you draw your cosine, you have to have half a hill, a whole valley, and the other half of the hill. All right, so even if I don't do one other thing, I have half credit right here because I know that's what a cosine looks like. All right, so let's start getting some more points. What are these going to be? What are these labels going to be? 1 and -1. Why are they 1 and -1? Because they're always 1 and -1 unless you put a multiplier here. Now, under normal circumstances, 90, 180, 270, 360. Those are the normals. I'm writing them down there because they're not the actual numbers. How do I know? Because I have a coefficient there. And what does that coefficient do? That divides. So it takes each of the normal numbers and divides by 2. So what are the new normal numbers? Or, I mean, not the new normal. What are the new numbers? 45, 90, 135, and 180. You're going to get even more points if you can tell me what the amplitude and the period are. Well, what's my amplitude? 1. What's my period? 180. You got it. That's it. That wasn't so hard. let's do a tangent. What do we know about the tangent? Let's just start with that. What do we know? Asymptote,
Negative 90, 90.
at negative 90, 90, and then a squiggle up through the origin, right? So let's just start with that. No labels, I'm just going to do the shape. Figure out the labels in a minute. There's my tangent. So, half credit. Tangents do not have vertical labels, so there's no labels on here, but they do have horizontal labels. And you already told me that they're supposed to be negative 90 and 90. But what have I done? I have divided by 1/4. So what is that term? I need the real ones here. What are the real labels going to be? Negative 360 and positive 360? On your calculator, 90 divided by 4. Which, by the way, is the same as 90 times 4. Period. Start to finish, that's period, beginning to end. What's negative 360 and another 3? What is 360 and another 360? 720. Period 720. What about amplitude? None. Tangents don't have amplitude because amplitude is height. And if I ask you how high that was, you couldn't tell me. Oh boy. Look at Jay. There's a lot going on in Jay. So I hope right now that you have drawn the picture of Jay, just the basic shape. What is the shape? What is the shape of that going to be? Well, it's a sine curve, right? And it is upside down. Starts at the origin because it's a sine. So I have my valley and then I have my hill. So there's my shape. All right, half credit. Now let's put some labels in. How high and low do I go here? 2 and negative 2. That makes my amplitude 2. My height is 2. Now I know that number is negative, but remember, amplitude is positive. It's a height. That hill is too tall. Normally, if I were doing just a regular sine, this would be 90, 180, 270, and 360. Those would be the normals. But I'm writing them down there out of the way because I've changed that. Those aren't the real labels. The real labels are those numbers divided by 1/3. Remember that dividing by 1/3 is the same as timesing by 3. So save yourself some grief with all the fraction stuff. You're just timesing by 3. So 270, 540, 810, and 1080, I think. I did that by head, so I need to check that. Which means our period is 1080. Okay, wow, that was a lot. But it was so incredibly fun. I'm going to have you and your partner try K. See what you can do with problem K.
Miss Ford.
When did that happen?
Like just now.
Makes for an interesting video when that happens. Yep, it's still rolling.
Try like putting it in the little one.
I try, but it doesn't stay in there. This case has never been very good. My old case was a lot better, but this one just has never been very good. But try to get it. So we'll see. Let me know if it falls again.
Okay.
Yeah. Oh wait. No, because it's cosine. So now start. Yeah, because it's reverse cosine.
So it starts at the 1/4.
Yeah, the peak does.
And then you go down.
Yeah.
Like that.
Yeah. And then 4 times 90.
Now, let's stop for a second before we get too far into it. Make sure everybody's on board. Have you all drawn a
Yeah, you do
cosine
divide
shape?
That's the same. That's the same.
Now, the thing about cosines, they're hard to draw because they look so strange. Remember that a cosine is going to end where it starts. Okay? And it's going to have a valley halfway in between. So it's going to come down and look like this. This is what your cosine is going to look like. Please don't draw more than that, because if you draw more than that, then you're going to try to label parts of it that you're going to get it wrong. So just remember, if it starts at the top, it's going to end at the top. All right? Okay, so everybody good with the shape? Have you started putting your labels in? What did you put here? Now, mine is obviously not to scale, because what should these be? These numbers. 1/4. Stop right now. You got kids, that's gotta be second nature. This number multiplies your amplitude. Look at your orange sheet. What is the normal amplitude? What are those labels normally? 1 and -1. So you're going to times them by 1/4. So they're going to be 1/4 and -1/4. So my amplitude is 1/4. Now, normally these labels would be 90, 180, 270, and 360. Remember, 1, 2, 3, 4 hash marks after the start. What happened? We divided by, this number divides. So now we're dividing by a 4. Which is the same as timesing by 4. So what, 360? Again, I did that kind of in my head, is that right? Yes. So, my period is 1440. And I'm done. How did we do with that? Well, does anybody have a question about that? All right, let's look at the next one, because it introduces kind of an unusual idea here. Alright, we're gonna do a tangent. What do we do? Two tangents. Alright, so tangent, asymptote, asymptote, squiggle up through the origin. Everybody good with that? Now we need to start putting some labels in. Well, remember, there are no labels on the y-axis in a tangent. What am I supposed to do with that? Multiply the height? Wait, do I have any height? No, so the 2 I ignore. The only time I pay attention to the 2 is if it's negative, because that matters, right? That turns me upside down. But in a tangent problem, I can put whatever number I want out there, and it is not going to change any labels at all, because I don't have any labels vertically. My amplitude is still none. So I'm ignoring that 2. Doesn't do anything. Now I can't ignore this though. So normally my asymptotes would be here. Those would be the normal places for them. But what is this number doing? It's dividing, and dividing by a fifth. I'm dividing by a fifth. And I can either divide by a fifth or I can multiply by 5, same thing. So I got negative 450 and positive 450. Which means my period is 900. Tell me this is the most fun you've had all day. I know it is. Let's try M. Y equals tan 10x. We love our tangents because they're so easy. So have you drawn your shape? Have you drawn an asymptote, and a squiggly line? And your amplitude is right. Now our period. Normally, negative 90 and 90 are my asymptotes. What have I done this time? Divided by 10. Remember, I divide by this number. Whatever that number is, I divide by it. This time I'm dividing by 10. So where are my real asymptotes then? Negative 9 and 9. So what is my real period? 18. You guys are pros. One more. Sine 2/7x. First thing I'm going to do, and I hope the first thing you do, is draw your sine curve. Ends right where it starts, just like the cosine. Alright, let's put some labels in. What about vertical labels? What are my vertical labels going to be?
1 and -1.
1 and -1. Which means my amplitude is 1. The amplitude of a sine is always 1, unless you put a number in front. These guys should be 90, 180, 270, and 360. What have I done? What have I done? I divided them by 2/7. So you are either gonna divide all those by 2/7, or you're gonna multiply them by 7/2. Whatever works for you. Somehow come up with the numbers. So 90 divided by 2/7. Quit looking at the clock, Macy. 90 divided by 2/7 is 315. That's what I got. Hopefully that's what you got. This one will be 630. 945. 1260. Okay, how's that work? All right? Now, little shortcut, guys. See how that was 315? To get this next one, just add another 315, and another 315, and another 315, because these are all evenly spaced. So once I know what that is, I know these are all going to be the same thing. Or you can figure them out by division. All right? Nas, sit down. I'm not done talking. What's my period for this problem? 12:60. 4-4 homework will be due on Tuesday. 4-4 due on Tuesday. Remember our little quiz on Monday, Monday, unless you want to stay after school and take it to
Yeah, so like.
Yeah. They're all over the place, but I know there's one here. Thank you, Charlie.
Thank you.
Okay, Charlie. It's your trademark. Before I knew you, even who you were,